the next session of finite element analysis. In the previous session, we have discussed about basic concepts of FEA and its prevalent use in the industries. After advancement in softwares like ANSYS, NISA, Nastran, MSc Adams, etc., these softwares are largely based on matrix algebra, and hence it is desirable that we discuss a little bit of matrices and their operations. So here you can see I have started with the representation of matrix. This is how a matrix is represented. A is, say, the matrix, M into N is the order of the matrix. Now I have taken an example here. A is 4 by 3. You can see there are 4 rows and there are 3 columns. So you can read here, M value over here is 4, which indicates the number of rows, and N over here is 3, which indicates the number of columns. Each number in the matrix is called as an element. If you look at this matrix, each number in the matrix is called as an element. If you observe here, 1 is an element, 2 is an element. Likewise, all the numbers written over here are called as element. Example, Aij. Now this is something very different and important. I and J is again going to indicate the row number and the column number respectively for a particular element. So the small a is 1, suppose it is in the first row and the first column, hence A11 is equal to 1. Similarly, Aij 31, 3 means the third row and the first element, which is 7. I can also read the fourth row in the third column over here is -2. So if I want, I can write down A43 is equal to -2. And so on you can write for all the elements. So this is how a matrix and an element in it is represented. Next, let's talk about some types of matrices. First one is called as a row matrix. A row matrix means there is only one row. Like you can see A, B, C. These are the 3 elements. There is only one row. Or I can take 1, 4, 9. This is another example. Next is column matrix. A matrix which has only one column is called as a column matrix. Like you can see here A, B, C. These are the 3 elements held in a column, single column. So it is called as a column matrix. Here also you can see there is 3 elements. Now I'll just write down something for you. This is a row matrix. As you can observe, there is only one row, correct? So number of columns is going to be 3. So 1 by 3 is the order of matrix. Same way here also I have written 1 by 3. If you want, you can write a 1 by 2 also. Say it is 1 and 2. This is 1 row, 2 columns. So this is also called as a row matrix. Column matrix means the column number should be 1 and there can be n number of rows. So here if you see, there are 3 rows and there is only one column. Same way here, 3 rows, 1 column. You can have 1, 2. This is going to be 2 rows, 1 and 2, and there is only one column. So it is 2 by 1. So this is how a row and column matrix is represented. Next, let's talk about square matrix. It is a matrix where number of rows and columns are equal. You can see here order is 3 by 3, 3 by 3, 2 by 2, 1 by 1. This matrix with only one element, that too the value is 0, this is called as a null matrix or a 0 matrix because the value is 0. So this is all about square matrix. Next, square matrix can also be written in various other forms. Now look here, square matrix A is called as a symmetric matrix if Aij is equal to Abi for every I and j. Now look carefully. A, D and F, these are the 3 diagonal elements. You can see this is forming a diagonal over here for the matrix. If you observe this and this element, the value is same. Now let's observe the position. I'll just mark the row number. This is 1, 2, 3. Column number is 1, 2 and 3. So when I have 3 rows, 3 columns, if I observe this element B, I can see its position is first row, second column. So I can say it is A1, 2. Similarly, this B is in second row, first column. So it is A2, 1 and the value is B. Similarly, A13 and A31 have the same value. A32 and 23 have the same value. So you can see B, C and E. These are forming elements such that they are symmetric above and below the diagonal. So this kind of a matrix will be called as a symmetric matrix, and obviously it has to be a square matrix. So this is that matrix A. So just label it A. Next comes square matrix with all non-diagonal elements as 0 is called as diagonal matrix. Now if you observe the matrix that I have written here, A, B, C are the diagonal elements. All the other elements are 0. So this type of matrix or this type of a square matrix, which is 3 by 3 order, will be called as a diagonal matrix. Also you can have something like this, A, B, and these term is 0. So this is a 2 by 2 diagonal matrix. So we can have 2 by 2, 3 by 3 and likewise more of them. Now suppose if a diagonal matrix with all the diagonal elements is 1, this will be known as a unit matrix. If you observe here, all the diagonal elements are 1 and rest of the elements over here that you see are 0. So this type of a special diagonal matrix is called as a unit matrix. Now this is a 3 by 3 type, this is a 2 by 2 type. You can also have a 1 by 1 diagonal matrix, which is very important because it is written that diagonal matrix has diagonal element as 1. So this is a diagonal element. Rest elements are 0, but here there is only one element. If you want to write a 4 by 4 matrix, it will be something like this: 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So here is a 4 by 4 diagonal matrix, and likewise you can continue writing for n number of diagonal matrices. Next, let's talk about a square matrix which has all the elements below the leading diagonal are 0 as 0. It is called as upper triangular matrix. Now observe A, D and F are the diagonal elements. You can observe there is a small triangle which I can form with the elements below the diagonal. When you have all these elements as 0, it will be called as upper triangular matrix. Now similarly, if you have a square matrix wherein above the diagonal you can form a square like this with the zeros, this will be called as a lower triangular matrix. So these are all the types of matrices which we need to know. Next we'll start with some matrix operations. This is very important as far as FEA subject is concerned because you are going to use a lot of addition, multiplication, subtraction throughout your FEA subject. So let's start with the basic of equality of matrices. Now two matrices can be called equal when the order of the two matrices are same. So let me write A is going to be a 2 by 2 matrix, and let's say B, which is also going to be a 2 by 2 matrix. Okay, so I will say that these two matrices are equal. So first condition is the order will be same. Second is each element of one matrix is equal to the corresponding element of the second matrix, which means if A is 1 2 3 4, B also has to be 1 2 3 4. Now I should have the corresponding, means the position. First column, second column, first row, second row. You can observe first row, first column, element is 1. Again first row, first column, element is 1. Which means they all should be equal in both the matrices. So this is just a basic rule of equality of matrices. Next we have matrix addition or subtraction. You can add two matrices A and B only if they are of the same order. Like I just wrote 2 by 2, 2 by 2. So this order has to be same. The elements need not be equal in both of them, but they have to be of the same order. Only then you can add or subtract two matrices. I think you have already studied this in mathematics, so I'm not taking up more examples on this. We'll just shift to multiplication of a matrix by a scalar. This is done by multiplying each element of the matrix by the scalar. You can observe k is a scalar value. This value of k can be anything. It can be 1, it can be 2, it can be 1 by 2, it can be 1 by 3, it can be any other number. So what you do is, if this is a common number which is outside, you just have to multiply with each element and write the final answer. So this is how multiplication of a matrix is done by a scalar. If you are aware of the fact only multiplication in matrices is possible, division is not possible. So what you can do is, you can actually multiply with a scalar like this. And that is how you divide each term by a particular common number, as division of matrices is not possible. Next we will definitely talk about multiplication of two matrices. Two matrices P and Q can be multiplied only when number of columns of P is equal to the number of rows of Q. Now observe here, P and Q are the two matrices that I have written. This is the order of the entire matrix and this is the order of the second matrix. If you observe, the number of columns of P should be equal to the number of rows of Q. Only then you can multiply these two matrices. Now how am I supposed to multiply them? P is multiplied by Q. So I'll just write down the matrix. Now observe, the resultant matrix which I'll obtain, so I'll call it as R, which I obtain, will be of order. If you see 4 and 4 are equal, so I have multiplied. Whatever number is pending, 3 by 2, 3 indicates the number of rows of P. So I'll have 3 as the number of rows of the resultant matrix and 2 is the number of column for Q. So this number will be taken up by the resultant matrix. Whatever remains, just write it for the resultant matrix. And now I'll show you how do I multiply. So R 3 2 will be. Now look, how do I multiply? I'll have 3 rows. So 1, 2, 3. I have 2 columns, 1 and 2. My order is 3 by 2. This is something that I write here. Now how do I multiply? I'll multiply 1 into 1. Then I'll multiply 2 into 2, 3 into 3 and 5 into 4 and add all these values that I get. So the first value over here will be 1 into 1 plus 2 into 2 plus 3 into 3 plus 5 into 4. So this becomes my first element or the first row. This is my first row, first column value. For the second one, okay, let's write it here. For the second one, I am going to multiply 1 into 5 plus 2 into 6 plus 3 into 7 plus 8 into 5. Now if you add them and you multiply, you will get the value as 5 plus 12 plus 21 plus 40. Next I am going to multiply for the second row and first column. So 6 into 1 is 6 plus 7 into 2 is 14, 4 into 3 is 12 and 8 fours are 32. Next for this column I am going to write 6 into 5 is 30, 7 into 6 42, 4 into 7 28 plus 8 into 8 64. Likewise 9 plus 0 minus 3 plus 4 and I have 45 plus 0 minus 7 plus 8. These are the values that I get. Now when I sum it up, I get the matrix as, so this is the value of the resultant matrix R 3 by 2 that I obtained by adding and placing these values. So this will be a 3 by 2 matrix that you can observe. So this is how a simple multiplication of two matrices is done. Next, let's talk about some related terms with matrices. First one is transpose of a matrix. The matrix formed by interchanging the rows and columns of the matrix is known as a transpose of matrix. Let's observe. A has element 1, 2, 3, 4, 5, 6. It has 2 rows and 3 columns. When I write the row as a column, if you observe here, 1, 2, 3 becomes a column, 4, 5, 6 becomes another column. This matrix which is formed now will be called as transpose of matrix A. It is denoted by A dash or A raised to T. This T stands for transpose, so A transpose. This is how it is written. You can observe the order was 2 by 3. It has now become 3 by 2. Next is adjoint of a square matrix. Adjoint of a square matrix is the transpose of the matrix formed by the cofactors of the elements in the determinant of the matrix. Now this is a matrix A which is given to me. This is of order 3 by 3. I'll have to first find a matrix which is formed by the cofactors of the elements in this matrix A. So let's start. So therefore I'll have determinant of the matrix which I have to find. For finding this, I'll have to do a very simple calculation, which is, suppose if I am calculating the cofactor for the first element 1. For that, first I'll have to forget the row and the column in which it is present. So suppose if it is present in the first row, first column, forget it for some time. Now you can observe there are 4 more elements that you can see. Just simply multiply 5 into 0 minus 6 into 8. So you will get 5 into 0 minus 6 into 8, which is equal to minus 48. So this is the cofactor of the first element, which I am going to write over here. Next, suppose if I have to calculate for 2, I'll forget the second row and the first column. It is the place where it is existing. So if you forget these two, what remains is 4 into 0 minus 6 into 7. So I get 4 into 0 minus 6 into 7. So I get the value as minus 42. So this is the cofactor for the second term. Likewise, you can calculate for all the other terms. Now here I would like to add one thing, that since we are calculating the determinant of this matrix, as you have seen over here, so this is called as determinant of this matrix, as you can observe. Now this matrix which I am forming over here, this is called as a cofactor. This entire matrix will be cofactors of each element. Now apart from writing these values over here, you also have to multiply with minus 1 raised to the summation of the row and the column in which it is present. For example, if it is in the first row, first column, it will be minus 1 raised to 1 plus 1. 1 plus 1 is 2. So minus 1 square will be 1. So I leave it as minus. Next term for the second one over here will be minus 1 raised to 1 plus 2. So minus 1 raised to 3 is minus 1. So here another minus sign will be added. So this becomes plus. When you see this term, it is minus 1 raised to 1 plus 3, 4. So again this will be 1. Minus 1 raised to 4 is 1. So multiply, it will still remain the same. Next over here, it is 2 plus 1, 3. So minus 1 raised to 3 will be minus 1. So this is another term. Now likewise I'll calculate for all of them. So these are the values that I obtained. Now again I'll solve for this element. Here it is minus 1 raised to 4, so it is positive. Here it will be minus 1 raised to 5, so negative. So I'll just change the sign here. Now I'll just give you a small hint if you don't want to go around doing this completely. These are the 4 places. If you see, there's a kite which I can form. This and these. These are the 4 corners. This is a kite which I have drawn where you need to change the sign. I would explain you why. Because these are the 4 positions where minus 1 raised to this m plus n is going to become odd. So when I have an odd number here, minus 1 raised to odd number is always minus 1. And minus 1 raised to even will always be plus 1. So these are the 4 places where I'm always going to get a minus 1 raised to odd. So you can just remember as a trick also that after finding all the values by closing the position of the element, by closing the row and the column of the element position, what you can do is you can calculate the values, then just change the sign for these 4 elements. So this is just a trick for remembering as to which element's sign has to be changed. Now I have formed a matrix which is formed by the cofactor of each element. So this is how it is calculated. Next I am going to write down directly the adjoint of matrix A. Now the adjoint of this matrix A can be written from here by simply finding out the transpose of this matrix. For that I am going to convert the row to column and the column into row. So this minus 48, 42 will come as a column value and minus 3 will be placed here. Next 24 shifts here, 21 is here and 3 at this position. And last I have minus 3, 6, minus 3. So this is the adjoint of this matrix A which I have found. Last I want to talk about an operation which is called as inverse of a matrix. If A is any square matrix, then its inverse is denoted by A inverse. And A into A inverse is equal to I. So this is one formula which you need to remember. This A inverse can also be given by another formula, that is adjoint of A upon mod of A. You just saw I calculated adjoint of A. You know how to calculate mod of A. Mod of A is nothing but the determinant value. So determinant calculation can be directly done on the calculator for a 3 by 3 matrix. If it is more, you need to manually solve it. So just by calculating determinant of a matrix and the adjoint value, if you divide both of them. Now when I say divide, it doesn't mean that I actually divide here. It means it is multiplied with a scalar value. If you understand, I have multiplied this 1 upon A into adjoint of A. So with this, I end this session. In the next session, we will discuss about another technique for calculating the inverse of a matrix. In case the matrix becomes more than 3 by 3, it becomes very difficult to solve by these formulas. So I'll show you another method which is called as Gauss elimination method. I hope you have understood the lecture. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.